So it came to my attention that a lot of students still have issues with the back surfaces, and the first thing I should go over is that you cannot just simply do a fillet edge. If you do a fillet edge and select all of the edges, and let's go from the side view and do that really quickly, what you end up with is a fillet, and then everything meets right here, and it's able to build the fillet, but it's not trimming the surfaces. And then everything comes down to a single point. So you have to manually resolve these fillets because they're not going to be able to be built automatically using the fillet edge command. And so the first thing I want to go over is why that's happening, and then I'm going to go over how to fix it. So the reason why this happens, I'm going to explode it first. The reason why that happens is because these four sides, they're all three-sided surfaces. So each of these surfaces is three-sided, and then you can see it here, this fillet ends up coming down to a single point. And so you're asking the software to do what's called a bad surface, because it's creating a three-sided fillet surface. And obviously you never want your surfaces to be three-sided. And this one is actually a three-sided surface too. Let's see the points. Yeah. And so you never want three-sided surfaces because what it does is it breaks the UV of the surface. So all surfaces have a U orientation, which is kind of like the X orientation of the surface, and then a Y orientation. And so whenever you have a single point from both directions, like this is U, U, and then here there should be a U, but there isn't because there's only a single point instead of two. So whenever you have that kind of situation, the software is going to have a really tough time creating these fillet surfaces. And so that's why that happens. And now we're going to go over how to resolve that type of surface. If we wanted this surface to be kind of like this, I'm going to show you exactly how you can achieve that manually by trimming the surfaces. So the first thing you want to do is explode all of your surfaces. And then I'm going to go in from the front side. And I'm going to make it really easy for myself and just select one of these edges and then go straight to the center. So I'm going to hit the ortho command. Grid snap, yeah, let's do grid snap. And so that makes it really easy to snap to the center. Enter, and then I'm going to select this line, and I'm going to mirror this line from the y-axis. And then if I want to, I can even go in and scale in 2 dimension or just regular scale. And I use the same point here, make everything bigger. And then just to make everything quicker, what I'm going to do is delete each of the sides. In fact, I don't even need these transitional surfaces. I'm speeding up the video speed because I don't want to waste your time with this type of stuff here where I'm just selecting surfaces and deleting them. So it's important for you to go through the video and watch it, but at this time I'm just speeding up the process. You can untrim this fillet and you see that it's actually extending the surface further than it needs to be. So you could do that if you want to. And then the whole point here is for us to go in and let's see, yeah, okay, that's good. And we'll use these curves right here, select both of them, and then type in trim. Or you can also click on the icon, which is right here, trim and untrim. So we're going to use this view here, the front view, and just trim it from this view right here. And it seems to be having a tough time with this one. Yeah, it's okay. Yeah, sometimes when you zoom in, it doesn't look correct. I think it's because of a number of points. It's probably a degree 2. Yeah, it's part of the mathematics of the software, but it doesn't matter for this assignment. So anyway, just trim one of the quarters of your clock, and then you're already halfway there because you've got the top fillet, you've got this one, and everything is trimmed to have the right spacing for both the back and the front. And you'll see what I mean once I move forwards and kind of finish up the object. So I'm going to go in and do an array polar from this point. And we need 4 sections because there's 4 of them, 360, yep. And so we'll just do that, 360 degrees, yes, accept, and accept. So now we're left with all of the sides, one of the fillets, and we've lost some of the fillets, but we're left with a very consistent spacing between both the front and the back surfaces. So it's going to end up giving us smoother transitional surfaces and fillets in this case. So let's start with the easiest one, which would be this one here. Let's think about this. How can we build it easily? I guess we could make an arc. So another way you could do it is using a single curve, and there's a few different options you can use, but I like to use this one here because it gives you degrees. And for now we're going to use degree 3. The reason for that is because we can just go in, set up a single line, and then once we show the points, it gives us exactly 2 points to work with, which means we can match one side to be tangent, because tangent is going to pull the first point. If you did curvature, it would pull both points. So we want to pull the first point to be tangent with this edge, accept. Do the same thing with the other side, tangent. And then we can simply extrude, or we can do a sweep. So I'll just do a simple sweep with 2. And so there's going to be 2 rails, this one and that one. And then the cross sections will use the curve we just created, and then we can select another one, but for now this should do the job. And then we can even specify for both edges we do want them to stay tangent. And that's it, yeah. Press OK. And now you've got one of them. So instead of doing that over and over again, what I can do is go into the front view, array, polar, yes. Go right here to the center, and I'll go back and use the grid snap so it snaps straight to the X, Y. And we're doing the same features with 360 degrees. And that's it. So the next thing we want to do here is do the same method again. And so I'm going to speed up the process and do it extremely quickly using a degree 3 curve from here to here, from here to there, and then using the match command, aligning both edges of the same curve, enter, do it again, tangent, okay. And then we'll use the same feature again, doing a sweep, sweep 2, accept, using these 2 rails, and then the cross sections would be this one and that one, accept. And then using the same settings, using tangency on both sides, we'll get some really nice results. Now for this one, you can do the same process. You can go in and do a sweep 2, using both of these, and with the cross sections we can use this one and that one. And here we can keep it tangent, tangent, and we should get some really nice results. Now another way to get the same result is to go under the surfaces and you use the curve network. So the curve network it's quicker and it gives you pretty much the same result. So you select the curve network, select all 4 of your edges. The order doesn't matter. For a sweep 2, you have to select 2 of the sides and then 2 of the other sides. But with curve network, you can select them in any order, going clockwise or counterclockwise. So anyway, once you do that, once you select everything, you can press enter, and it's going to give you a bunch of options, and here you can force everything to be curvature or everything to be tangent. So if we try everything with curvature, we should get a very dense fillet, but it's going to be really smooth. Now, if we go with tangency, we'll get something really similar, but the surface is lighter than it was before, and you can see right away the more complicated it is, the more section you get. Yeah, you can see here by changing B, I forget which one it is, probably the C. Yeah, by changing C from tangent to curvature, suddenly you get more sections, and these are called spans. So anyway, it makes the surface more heavy, which makes your file more heavy, and sometimes you want it because it makes everything look better. In this case, tangency should work better for us, so we'll keep it tangent. It should give us some really good results. And then if you want to double check, what you would do is join all of your surfaces. So select them one by one and join them, and then go under the Analyze, Edge Tools, and you can show edges and make sure that they are joined correctly. So wherever you see the edge color being pink, it shows you where the naked edges are. And so right now these are joined together. And now what we can do is select the surface, go under Analyze, Surface, Zebra. So this gives us a really good sense of how smooth the fillets are and how nice the transition goes. So in this case we have good results. I'm sure if we did a sweep 2 it would give us the same result. So let's quickly go over it and just do a quick sweep 2. Set it up the same way as before. Accept, okay. And this time I'm going to take all of these fillets. I guess I don't need this one. And I'll duplicate everything to each of the sides. So again, the command I'm going to use is array polar. Press enter, go to the center point, accept, just pressing enter a few times, and then it duplicates everything. And now I'm going to go here, join all of my surfaces together, check if there's any gaps by going under the Analyze, Edge Tools, Show Edges. And shows that the gaps are here and here, which is exactly what we want. So now I'm going to go back and check if everything is smooth the way I want it to be. And it is. It looks pretty much the same as using the curve network. So that's basically how you do everything, and I'm just going to quickly show you that it does work on the backside. And again, I'm going to speed up the process because I don't want you to just sit there and listen to the same thing over and over again. And again, you can double check. Go under Analyze and check if everything is nice and closed off, and it is. So that's it. That concludes this demo on how to resolve these fillet surfaces on the backside of your clock.